Good day, everybody. We're going to start some tutorials here for XMD, and what we're going to do is we're going to essentially run through an entire mold design over several segments. So we'll start off with the very first segment being how to start a job. In XMD, one huge advantage in XMD is the starting of the job. We can start jobs several different ways. We're going to go through three different ones, three most commonly used ones, and they are to start with no part data, no data whatsoever in actual fact, so it'll be a completely empty file that we'll start with. And then we're going to start with part, and then we're going to start one with part and parting line. Okay? So what this allows us to do is allows us to start a job at any time we want. So I'm going to go ahead and start a new job. I'm going to call this no part. Okay, so this is basically there's no, actually we're going to change it, I'll call it no data. So there's no data, there's no nothing in there. Go ahead and say okay. So what it is I have absolutely no data in this job. This is a completely clean, fresh, empty job. I'm going to choose my configuration file and choose my title block. You can create different configuration files for different customers. We're going to go ahead and put part name in here and call it a housing. Even though I don't have a part, I can still give it whatever I want. And what this does, filling this information here, is this is going to actually fill in the title block for us. So we're getting a head start even on the title block. Everything we do, we're going to get a head start. So what we do here is, since we don't have any part data, but the customers come to us and said, you know, the part's going to be about this size. And a lot of customers will use this for quoting. So you can even do this. You can do this to actually create a job if you want, but you can also use it to just to get general quotes. So we're going to go ahead and put some part sizes in here. Okay, and I'm going to tell it I want to generate some parting line locks. So what it's going to do is it's going to give me some basic wireframe geometry of some locks and some parting line, just more for visual. But you can actually use that data, send it to the modeler, and the modeler can use that to generate their 3D. So we have 6 different options here, separated in 2 different categories. So 2 categories being male locks on the core half or female locks on the core half. So you can choose however you want your locks to be. We're going to go ahead and go with some corner locks, male on the core. Go ahead and say OK. So now what we've got here is you can see we've kind of drawn in a real basic part. It's just XMD has done that automatically for us. So I'm going to go ahead here and I'm just going to manipulate some part sizes. Okay. So there's different ways to change these blocks, and basically you can just kind of click on there and tell it to go ahead and give you whatever block sizes you want. We're going to go with let's go with some 20-inch blocks this way, and we'll add another 4 inches to this, so we'll go 30 inches this way. That looks pretty good. I can look at my plan view and I can see if I'm happy with my corner locks. If I am, great. If I would like to see, you know, a larger corner rad, I can click on there and change that rad. And maybe I want to make my corner locks 4.5 inches instead. So I'm getting some general feedback right off the bat. So there's no templates or anything that I've had to create for this. This is how the software comes to you out of the box. So you're able to just start using it. You don't have to create a whole bunch of crazy libraries to deal with this or anything like that. So I'm going to go ahead and say OK. And then we get our mold parameters when that pops up. So under our mold parameters, as you can see too, we already have some 3D parting line and lock just kind of quickly drawn in. So in here we can go ahead and we can make changes to the plate thicknesses if we'd like. It uses kind of some industry best practices for the plate thicknesses and sizes, but you can always tweak those as to whatever you want. Everything's totally configurable on the fly. So we're going to add a manifold spacer plate in there too, so you have the option of adding one, or just by hitting the checkbox you actually can remove it. And I can come back into here and make changes to these at any time. So I can add a manifold spacer plate when I'm 90% in my job. It doesn't matter. It knows exactly what to do if you do that. So I'm going to go ahead and say OK. And as you can see, it's populating some 3D plates automatically. Once again, this isn't something I had to pre-set up. Everything you're seeing is how it comes out of the box. Okay, so we have some 3D components drawn in automatically. As you can see, there's some guide pins, long screws, short screws, things like that. And I can configure a lot of these things to use certain things as default, so certain guide pin styles as default, certain setups of your long screws and short screws as default. But I can also make changes right from in here. So if I click on this long screw, I can say I want to change that mount pattern to a double mount pattern. If I say that, what it does is automatically puts a short screw at every single long screw and then counterbores the long screw in deeper, as you can see. So everything is very, very intelligent in the software. I can make changes at any time. I can change the styles and the types and the way a lot of these things work based on a lot of different standard ways that people do things. So for example, I have the stop buttons in the bottom clamp plate. And for a lot of our customers, that's how they go. So we have our configuration file set that way. If you do it a different way, you can change your configuration file, or maybe just once in a while you have to do it a different way. You can keep your configuration file the way you mostly operate, and you can click on this and say invert, and they all flip over to the other way. And that's the holes and everything are updated. So as you can see, the holes are back in there. Okay. So very, very automatic. Now, one thing just to let you know is while we've been working here, all the 2D drawings have been all generated. So everything is all generated on the fly simultaneously. I can make changes to components from within here, from my 2D drawings as well. So I'm going to say by group, which will move all the 4 symmetrical pillar supports at the same time. And if I go to my 3D, you'll see my 3D is also populated in that way. Okay? So everything is simultaneous and together. I can also, as you can see, get around my job very easily. I'm not trying to fumble around with an assembly setup or with levels or anything like that. I can get around very, very quickly and easily. As mentioned before, with our title blocks, we filled in some information at the beginning, like housing and shrink, and you can see all that stuff is filled in. From there, I can make changes to the title block or additions to the title block through this dialog box here. Right, so I can say it's a single cavity, injection mold. It could be a blow mold, it could be a compression mold, anything that you wish. You can put in your maybe polypro material, etc., etc. And you can put that you're all full scale or whatever you want, and you can go ahead and say when you're all complete and everything is done, you can go ahead and say OK, and this fills in, and that's filled in on the cavity plan and core plan and section A, everything. So all plan views all have that same stuff filled in. So very, very easy. I have a quick prelim already ready to go. I also can go to my material list, and if I go ahead and grab my configuration of material list here, as you can see, everything's being generated as we go. So I can go ahead and export this to an Excel file, and my purchaser can go ahead and start getting some stuff quoted right away if they like. Okay. So that is how to start a job with absolutely no part. Okay, so now that you've seen how it works with absolutely no data in the file, what we're going to do next is we're going to create basically the same exact mold that we just did, but this time we're going to start with some part data. So this is very, very easy to do. It works much the same way as what you saw without part. The only difference is we're putting part data in the file, and we don't have to actually type in the actual part size. So for example, in this case here, I put the data on level 200.1. And by putting on level 200.1, it's telling XMD this is part data. And we can put any type of data on there. So it doesn't even have to be a solid, it doesn't even have to be surfaces, it could be wireframe. It could be anything that you want. So it could be something drawn up, just a square block. It could be the actual part data, it could be partial data, it could be anything you need. So we're very, very flexible on the type of data that you work with, which makes things much, much easier for you to get started ahead of time, maybe before you're even actually kicked off. So we can go ahead, and that gives you an advantage on how quick you can get stuff to your customer for approvals and then out to the floor. So let's go ahead, and we're going to create this one. We're going to call it part only. Okay, and all the exact same things. The difference is I don't have to type in the part size because it understood the part size based on this data here. I can once again go in there and pick some parting line locks. So we're going to go ahead and do that again. And now it's asking me if I want to center this along the x-axis. We have a spot here that the customer actually put in specifically for where they want the drop to go. So that needed to be the center of the mold, which happens to be a little bit offset of the part. So what it's doing is it's letting you know that you don't have everything right on the center. Do you want it to be on center? And if you do, it'll actually move the part data for you. I'm going to say no, I don't want to move it. I don't need anything centered. Where I have it is exactly where I want it. Okay, so now I can go ahead and I can manipulate some sizes. So I'm going to go with the exact same size as I did in the first one, which is 20 by 30. I'm going to go ahead. I'm going to just go ahead and say OK here, and we're going to go ahead and generate this mold base much like the other one. We don't have to fill in everything. We can fill in what we want. In this case here, I'm going to leave it without a manifold spacer plate. That way I can kind of show you what happens when we add one. Go ahead and say OK. So now what we've got is we've got a cavity block, core block, all this stuff all being generated exactly like you've seen before. It operates the same way. You can see you've got the same components. This time, because I have some part data in there, it went ahead and it dropped in a cold sprue for me. You can configure to do that or not do that if you wish. And then from there, what we're going to do is we're going to go ahead and add. I'm going to go back in there. I'm going to add a manifold spacer plate. Once again, you could do this at any time in the design process. You could also remove one just the same. So I'm going to go ahead and say, put a 4-inch spacer plate in there. Go ahead and say OK. And it's going to go ahead. So you can see it's shifted everything up, and it's put the screws in we need, and it's increased the length of the sprue bushing. So it knows exactly what to do automatically. It's very, 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 very efficient. And these kinds of things work like this for everything. Maybe I'm not really happy with the amount of ejector stroke I have. Maybe I want less ejector stroke, for example. Well, I can go back in here and I can say, well, I want my ejector stroke to actually be 2 inches. Real short ejector stroke. They have good robot systems there. They don't need a long ejector stroke. This will be better for them in the long run. Go ahead and say OK. You see the ejector stroke change. You'll see the pillar supports get shorter. You'll see everything all adjust all automatically. And that's just how XMD works. It's absolutely fantastic. And once again, the 2D drawings are there. All those sections are all updated accordingly. And it doesn't matter if I'm in 2D or 3Ds. For example, if I'm in 2D right now and I change to a 3-inch ejector stroke and I say OK, you're going to see that ejector stroke change here in the 2D. So it doesn't really matter. It doesn't matter where we are. Okay, so now from here, what I want to do is I'm going to change my mind. I'm going to decide, you know what, I don't want a manifold spacer plate now. Do you want to delete everything that's associated to it? Say yes, say okay. It's going to get rid of those screws. It's going to shift everything down for me, and away we go. So very, very impressive software. It makes things very, very easy to get around. And these little tiny things, I mean, those changes I made are very, very rapid. And I'm able to produce a prelim or a final mold design as fast as I need to. Now we can do the same thing like I showed you before. If I take a look at the material list, you're going to see everything's there. I have my rail heights and everything else. Well, if I make those changes, let's go back into here and let's put the manifold spacer plate back in again. So we'll go back to a 4-inch, and I'm going to increase my ejector stroke now back to 4 inches as well. I'm going to say OK. When I go back into my material list, all that stuff's updated. So the manifold spacer plates added, the length of all these components that were in the ejector box, that's all updated in this material list. So this material list is a little longer now. I now have a manifold spacer plate in there. It's increased the length. It's added some extra screws based on what was put in there, things like that. So very, very rapid. And as you can see, it's the same result as when I did it without part data, and just as fast. Okay, so next for us is now to do the exact same thing we've done already without any data, and with just part. We're going to do the same thing, but with our part and parting line, and we're going to actually dictate to XMD where we want the back blocks and everything to be. So as you can see here, I have here, these are all just set up as surfaces. They're not actually solids, they're sheet bodies. And you don't necessarily have to have things quite as finished as you see here. You can have, some people do a bit of a combination of these 3 different ways. So some people put just the part data, and then they might just put just some corner locks like this. And what that does is that'll ensure that guide pins go to the heights they want right off the bat, and away they go. So you can really experiment with how you start these jobs and do different things. So we're going to go ahead and start with everything you see here. And I'm going to call this complete. Okay. So what this allows me to do, as I mentioned, is allows me to dictate to XMD how I want the blocks to be. So maybe you didn't have time to start the mold design, but you had time to start the modeling. So you did the modeling first. You can do that. Once again, complete flexibility in how we do things. Okay, so in this case here, I'm not going to put in part sizes, just for the same reason as the previous one. We already have part data there. And we're also not going to tell it to click on parting line locks, because we already have some. In fact, if I try to tell it to do parting locks, it's going to say user parting lines detected, XMD locks not permitted. So it knows we have data in there that represents the lock. So it's saying you're not going to actually click on the basic ones. You already have locks there. So we're going to go ahead and say OK. And all the sizes are all in there now. I don't have to worry about figuring out any of my sizes. They're all there and ready to go. So go ahead and say OK. And in here, what we're going to do is we're going to go ahead and say we can leave all the sizes the way they are. We can modify them however we want. Just no different than how we did before. We can add manifold spacer plates. Everything works exactly the same. The only difference is we've predetermined what those sizes we want to be for the core and cavity blocks. Everything else is exactly the same. So as you can see, we're going to go ahead and we're going to populate these, and we're going to have the job started, and there we go. One really benefit to this is, as you can see, looking in the plan views, looks a little bit prettier. We have a little more detail in there with the parting line and locks. This would be a really, really nice prelim drawing for your customer to approve steel sizes right off the bat. So just like that, just as quick as that, I produced a prelim in 3 different formats, 3 different ways, and you're able to utilize XMD in what works best for you, whether it's the way your organization always works, or it's based on the way that particular program is coming down. Maybe we haven't received data from the customer, but we need to get something kind of jump started so we can, or we received data quite a while ago, but they haven't given us the go-ahead for the mold design and all the information we need for the mold design, so we kind of got a head start on the parting line. So you can work however you want. We're totally flexible, and that is how to start a job 3 different ways.